Hello, today we're going to be looking at collecting like terms, and this is going to need us to use the skills that we learnt when we did adding and subtracting negative numbers. So, can you answer this question by pausing the video and drawing out counters or a bar model? Pause the video and have a go. So you should have drawn 3 negative ones to represent -3 and 5 negative ones to represent -5. You should have looked for any zero pairs, and there aren't any in this case, and then summed to find -8. If you prefer to draw a bar model, then you could have drawn a bar to represent -3 and a bar to represent -5. The bar for -5 is longer than the bar for -3 because its magnitude is greater. Then you look for any zero pairs, which there aren't, and sum to find -8. What about this question? Pause the video and have a go by drawing out counters or a bar model. So you should have drawn +2 and -4. Then you should have looked for any zero pairs, and there are 2 in this case, and then summed to find a total of -2. If you prefer, you can draw out a bar model with a bar to represent -2 and a bar to represent -4. The bar for -4 is longer than the bar for +2 because its magnitude is bigger. You then need to partition your -4 into a -2 and another -2 and look for your zero pair and sum to find a total of -2. So 5x, this means 5 lots of x or 5 multiplied by x. We can represent this by taking 5 counters which each represent 1x, making a total of 5x. We might also have a different variable. For example, we could have the variable y. 6y means 6 lots of y, or 6 multiplied by y. And we can represent this with 6 counters, each one representing 1y. So altogether we have 6y. We're now going to look at collecting like terms, and we're going to represent this sum with our counters. So we are going to need 4 x's, a row of 4 x's, and then another row of 3x. And all together we can sum to find that we have in total 7x. How about this one? Can you pause the video and try to answer this by drawing out counters to represent 6x, add 7x. So you should have drawn a row of 6 x's and a row of 7 x's, and then you should have summed these to find that in total you have 13x. What about this one? It's slightly different because we have 3 terms, but can you think about how you might represent this sum with counters? Can you draw these out and try to answer the question? Pause the video. Okay, you should have drawn a row of 4 x's, a row of 3 x's, and then for the third term, a row of 5 x's. And then we can sum these to find that in total we have 12x. This one is slightly different because the variable has changed. We now have a y, but the process is the same. Can you pause the video and have a go at answering this question by drawing out counters, this time with a y on? Okay, you should have drawn a row of 6 y's and a row of 2 y's, and then you should have summed to find in total you had 8y. When we did negative numbers, we looked at the idea of a zero pair, a positive one and a negative one summed together to make 0. We have the same idea when we're looking at algebra. Here we have a positive x and a negative x, which sum to make 0. So this is also a zero pair. It also works the other way round. Negative x add positive x together sum to 0, and so this is also a zero pair. So we're going to have a go at using counters to answer this question. This term here, 7x, does not have a direction, and when we don't have a direction, we assume the direction is positive. This negative here is the direction of the 4x term. So I can think of this as positive 7x add negative 4x. And I'm going to use my counters to draw a row of 7x's and then a row of 4x's. This time I'm going to look for any zero pairs, and in this case there are 4. Now I can sum what's left and find that I have a total of 3x. If we have a different variable, we can still have the idea of a zero pair. Here we have a positive y and a negative y, which sum to make 0. And the other way round, negative y add positive y sums to make 0. So these are also both zero pairs. Could you pause the video and try drawing out counters to help you answer this question? Okay, you should have drawn a row of 8 negative y's and then a row of 3 positive y's. You need to look for the zero pairs. In this case, there are 3. And then sum what's left to find that the answer is negative 5y. So our 8x here doesn't have a sign on the front, so we're going to assume that this is a positive 8x. This negative here is the direction of the 3x, so we are adding to the positive 8x negative 3x, and then we're adding positive 5x. So I can think of this as positive 8x add negative 3x add positive 5x. So here I'm going to have 3 rows. The first one is a row of 8 positive x's, then a row of 3 negative x's, and then a row of 5 positive x's. I'm now going to use the commutative law to group together the positive 8x and the positive 5x. So this has summed the positive 8x and the positive 5x. Now I can look for any zero pairs, and I have here 3. And now I can sum what remains to find a total of 10x. If at this point you would rather draw a bar model, that's fine. You would need here to draw a bar to represent 8x, a bar for negative 3x, and then a bar for positive 5x. I can then use the commutative law to collect my positive x's together. I'm going to need to partition my 8x into a positive 3x and a 5x. Look for the zero pair, and then sum to find a total of 10x. This one is going to need us to use the rules that we learnt when we were adding and subtracting negative numbers. In particular, a subtract changes the sign. So here I can draw 7 y's, 3 negative y's, but I'm subtracting these. So a subtract changes the sign. I need to flip my counters and then sum to make 10y. I could do the same with the bar model, and I would need to flip my bar to make a positive 3y and then sum. Can you pause the video and have a go at drawing out counters to help you answer these questions?